18 February 2026, first class on interference. And in this class, we are solving past paper question. Theory we have completed yesterday. And the question is, sir, this is source number one and this is source number two. Sir, these are two sources. And consider these two sources are producing water waves. These are water waves in a ripple tank. Okay. And the question is, what is happening at position A? What is happening at position B? And I think both are very difficult to explain. So I am starting with easy example. The example is if I ask you what is happening at point P. I am asking at this point P because you can see, sir, at point P, this is dark wavefront. This is dark wavefront. It means, sir, both wavefronts representing crests. And you know when crest lie on crest of other, sir, there will be constructive interference. So at point P, sir, there will be constructive interference. And if there is constructive interference, then obviously there will be maximum vibration observed at point P. Okay. And in the last class, I taught you that if examiner draw dotted wavefront, then this dotted wavefront actually it is representing trough of the waves. It is representing trough of the wave. In the same way, and remember the dotted wavefront which I have drawn, it is coming from source number two. It is coming from source number two. Okay. And if I draw another wavefront between these two wavefronts, and I should change color, and this green wavefront. So this green wavefront, actually this is produced by source number one. And as I said, sir, this dotted wavefront representing trough. And you know when trough lies on another trough, then Simra, what will be there? Constructive interference or destructive interference? At point A, there are trough, dotted red color, dotted green color. Both are trough. If trough lies on trough, then what will happen at point A? Simra? Yes, there will be constructive interference. There will be constructive interference. Okay, number one. Number two, I can explain, I try to explain this question by another way. And the way is if I start from here, then it is one wavelength, then two wavelength, three wavelength, and this is 3.5 wavelength. This distance is 3.5 wavelength. This distance is 3.5 wavelength. Okay. And now I am drawing from here. Sir, one wavelength, two wavelength, three wavelength, four wavelength, 4.5. Sir, there is 4.5 wavelength distance. And if I calculate their path difference, sir, then it is 1 lambda. And you know, if the path difference is 1 lambda, if the path difference is 1 lambda, then there will be constructive interference. So at point A, there is constructive interference. So I am writing answer. The question is explain type of superposition taking place at position A. But I am writing not only the answer, but actually I am trying to explain what is happening at point A. Okay. So for point A, the path difference from S1 and S2 Walaikum Salam Abdullah. From S1 and S2 is is 4.5 lambda minus 3.5 lambda is equal to 1 lambda. So trough lies on trough. So thus due to constructive interference, due to constructive interference, maximum downward vibration, because both are trough, maximum downward vibration is obtained. If crest lies on crest, then upward vibration observed. If trough lies on trough, then maximum downward vibration is observed. So I have explained in both ways. Way number one, sir, path difference is 1 lambda. Way number two, sir, trough is on trough. When trough is on trough and the path difference is 1 lambda, and then there will be constructive interference. So I have explained earlier, and now I am moving forward for position B. And the same method I will try to use. Okay, so let's start. Sir, from source number one, count. Source number one, beta count. One wavelength, two wavelength, three wavelength, 3.5. 3.5. Sir, this is 3.5 wavelength. It is the path. It is the length of path from source number one. And now from the source number two, measure or count 1, 2 lambda, 3 lambda, 4 lambda, 5 lambda. So this length is 5 lambda. So if I ask you what is the path difference, so 5 lambda minus 3.5 lambda. So the path difference is 1.5 lambda. And Banin Bata in the last class we have studied if the path difference is 0 lambda, 1 lambda, 2 lambda, 3 lambda, 4 lambda, then it is constructive interference. And if path difference is 0.5 lambda or 1.5 lambda, so there will be destructive interference. And if there is destructive interference, then no vibration is observed at point B because it is water wave. So I am writing, sir, for point B, the path difference from S1 is source number one, and source number two is is 5 lambda minus 3.5 lambda. So the path difference is सही है 1.5 lambda. So so crest lies on trough. You know 5 lambda means there will be crest, and 3.5 lambda means there is trough. 5 lambda means there will be crest from source number one. From one source, I am not saying source number one. So 5 lambda is from source number two, okay. And this point 3.5 lambda represent trough, okay. So crest is passing on trough. So, thus, due to destructive interference, due to destructive interference, no vibration is observed. No vibration is observed or obtained. So actually this question making your base, okay, how does constructive interference, how does destructive interference take place? If the path difference is of order 0 lambda, 1 lambda, 2 lambda, 3 lambda, 4 lambda, then there is constructive interference, maximum vibration. If the path difference is 0.5 lambda, 1.5 lambda, 2.5 lambda, then there is destructive interference, no vibration is obtained. So actually this type of question making your base. So this is question from January 2021, question number 12. I have explained, I am recording, so I should move to the next question. And the next question is here. So this question is not about water wave. So this is about light. Okay, it is of same kind. Consider this is a laser light. This is a laser light, and in this laser light, this is source number one, and this is source number two. Okay, these are two sources, and we are given wavelength. Okay, and now the question is about point O, about point O, and you are given point A O is equidistant point. Point O is equidistant point, the distance from A to O and the distance from B to O, it is equal. Sir, if the distances are equal, if the distances are equal, so there is no path difference. There is no path difference. Sir, it is given points are equidistant. If the points are equidistant, equidistant means equidistant means zero path difference. No path difference. It is condition of it is condition of constructive interference. It is condition of constructive interference. So wave will superpose on each other in phase. The key word is in phase. Sir, in phase means crest on crest or trough on trough. Okay. Now I am changing the vocabulary. When I am writing in phase, sir, in phase means crest on crest, trough on trough. So there is constructive interference, and due to constructive interference, sir, if it is light, then obviously a bright line is formed at this point. A bright line is formed at this point. Okay, so when the two waves superpose in phase, there is constructive interference. When the two waves superpose anti-phase, then there is destructive interference. If it is a light, then bright line or dark line are formed. If there is a sound, then a louder sound or a faint sound is produced. So this question is completed. But there is one more question is remaining. The question is, so the next bright line is observed on the screen at point P. It is the next bright line. Next bright line. Okay. It is the central bright line and it is the next bright line. But Zainab, can you tell me if the central bright line having path difference 0 lambda, then what will be next path difference? If you have memorized the sequence, then I think you can tell me if the central point having path difference 0 lambda, then what will be path difference for the next bright line? Zainab. No, no, no. It will be 1 lambda, beta. 1 lambda. Directly 2 lambda पे आपने क्यों छलांग लगा दी? It is 0 lambda. It is 0 lambda. Then the next will be 1 lambda. Okay. And if I ask you in terms of phase difference, then phase difference should be 0 pi, then 2 pi. I think you confused, I think, in lambda and pi, I think. हाँ बेटा जैनब, क्या आपने ऐसे ही किया लैम्डा को पाई के साथ मिक्स कर दिया बेटा क्या? हाँ वो इवन वाला फेज है, इवन वाला फेज है, ठीक है ना? इफ द क्वेश्चन वुड बी व्हाट इज द फेज डिफरेंस, अगर वो कहता ना बेटा फेज डिफरेंस, तो फिर आप उस पर चले जाते. इन दिस क्वेश्चन दे आर आस्किंग स्टेट द डिफरेंस इन लेंथ, and length means path. And if they are talking about path, then the sequence is 0 lambda, 1 lambda, 2 lambda, 3 lambda. So the next answer is from 0 lambda to next answer is sir 1 lambda. And if the wavelength is given, if the wavelength is given, yes sir, wavelength is given. It is 600 nanometer. So I should write, sir, path difference will be 600 nanometer. Path difference is 600 nanometer. Path difference is 600 nanometer. Okay, so this question is completed. And now another question. This question I did not write the air. Okay, in a concert hall, sound wave produced by an instrument are reflected from different parts of the hall. The two coherent waves. I will explain you the meaning of coherent, but abhi nahi. The question is, if the phase difference is pi, Banin, you have to answer. Banin beta, if the phase difference is pi, then what is path difference? Banin beta, when the phase difference is pi, then what is path difference? You are saying lambda by 2, and I think you are right. I think you are right because I taught you, sir, phase difference sequence is this. Sir, 1 pi, 3 pi, 5 pi, 7 pi. Okay, it is phase difference. And corresponding lambda form, sir, it is lambda by 2, 3 lambda by 2, 5 lambda by 2, 7 lambda by 2. So you are right. Pi means lambda by 2, one way. And sir, we have another way. You know, sir, 1 lambda is equal to 2 pi. When we studied the topic of phase difference, then I taught you, sir, 1 lambda is equal to 2 pi. And if I divide both sides by 2, then obviously pi radian is equal to lambda by 2. So your answer, Banin, in both ways, in all ways, it is perfect. Assalamu alaikum, बेटा मनाहिल. अच्छा बेटा, कोई बात नहीं बेटा, कोई बात नहीं, रिकॉर्डिंग से आप देखिएगा इसको. अच्छा बेटा, नाउ क्वेश्चन नंबर 26. क्वेश्चन नंबर 26 बेटा ये है, a stationary interference pattern is created by superposition of waves from two sources which are close together. Okay. For this to occur, the waves must be. So the question is very, very simple. in which stationary interference created superposition of wave two sources which are close to. For this to occur, the wave must be. Okay. So remember, the basic condition of interference is the waves which are superposing upon each other. I should write conditions, then I should explain answer. Note down the condition of interference. Sir, condition of interference are condition number one. Sir, waves should be of same nature. I mean, light interfere with light, sound interfere with sound. It is not possible कि sound interfere with light. ठीक है ना? तो it is nonsense. Condition number one, wave should be of same nature. Number one. Number two, waves should be coherent. Sir, what is the meaning of coherent? Coherent means their wavelength and frequency should be same. Frequency and wavelength should be same. Okay. And in this question, the you are given option only same frequency. Okay. But I think you should memorize the term coherent. Coherent means same frequency, same wavelength. And in Cambridge board, coherent wave is explained by another different difficult way, which I am not rightly explaining. So coherent means same frequency and same wavelength. Okay, so it is condition number two. And now what is the condition number three? So condition number three is waves must superpose upon each other. Superpose upon each other. If one wave is moving left side, the other wave is moving right side. If they are not meeting, then no interference possible. So there are three conditions of interference. Number one, waves should be of same nature. Number two, coherent. Number three, superpose upon each other. So the answer of this question is D. Same frequency means coherent waves. And now the next question. The two waves of wavelength lambda from a single source diverge and then meet again. Okay, which of the following situation would cause constructive interference? So this is very simple question. Simra, can you answer? For constructive interference, what is the condition? Simra? Oh no. If the path difference is 1 lambda by 2, 3 lambda by 2, 5 lambda by 2, it is condition of destructive interference. If the path difference is 1 lambda, 2 lambda, 3 lambda, 4 lambda, 5 lambda, yes, this is the condition of constructive interference. And in option C and D, they are not talking about the path difference, they are talking about the phase difference. And I taught you the phase difference is even multiple. This is odd multiple. This is odd multiple. So it is condition of destructive interference. And the condition of constructive interference is not given in terms of phase difference. So the only right choice is path difference of the two waves must be lambda. And now the class time is ending.